All right, so you've got a dead phone in your hand. You're staring at it and you're thinking, where do I even start? Well, what if I told you that the key to figuring it out isn't some super expensive piece of gear, but just a simple beep? Yeah, you heard me. Today we're going to dig into how one little sound can basically help you fix almost any phone.
And look, forget all that complicated software stuff for a minute. I'm not talking about diagnostics apps. No. We're talking about the actual physical parts. You know, a busted speaker, a bad cable, maybe a blown fuse. Just imagine being able to find the exact problem just by listening. That's what we're going to do. We're going to turn you into a hardware detective, and all you'll need is one super simple test.
Okay, first things first. Let's meet our main tool for the job, the multimeter. Now, you can kind of think of this thing as a doctor's stethoscope, but for electronics. It measures all sorts of stuff, but honestly, we're going to ignore most of the complicated settings. And we're specifically focusing on the digital kind, because that bright, clear screen, it gives us the super simple, easy-to-read answers we're looking for.
Yeah, this thing can measure voltage, resistance, all that technical jazz, but like I said, we're just going to ignore all of that for now. We are dialing in on one single setting. See that little icon, the one that kind of looks like a sound wave or a buzzer? That, my friends, is continuity mode. And trust me, it is about to become your absolute best friend when it comes to fixing phones.
So, when we flip that dial to this mode, what are we actually testing for? Before we start poking around on a circuit board with those probes, we really got to get our heads around this one core idea, continuity. So let's break down what that word really means. Okay, in the simplest possible terms, continuity just means you have a complete, unbroken path from point A to point B. That's it. If electricity can flow freely through a wire or a fuse or whatever component without hitting a dead end, well, that path has continuity. And if that path is broken, we call that an open circuit.
You know, here's a really great way to picture it. Think of an electrical circuit like a train track, right? If all the rails are connected perfectly, the train, which in our case is the electricity, can chug right along to its destination. That's your complete path. That's continuity. So an open circuit is just a broken track. Simple as that. The train can't cross and everything just grinds to a halt.
And here's the absolute best part. The thing that makes this so powerful. You don't need to read any complicated numbers on the screen. The continuity test gives you a simple, audible answer. It literally tells you, with a sound, if that train track is clear or if it's broken. There are only two results you need to listen for.
It really is this simple. It's totally binary. If you put your probes on a component and you hear that awesome, satisfying beep, that means the path is complete. You've got continuity. But if you hear nothing, just silence, that means the path is broken. It's an open circuit. So basically, beep equals good and silence equals bad. Well, most of the time anyway.
All right, so theory is great and all, but let's see how this actually works in the real world, right? It's time to take this test and apply it to the actual components you'd find inside a phone. This is where that simple little beep really does become your diagnostic superpower.
So let's start with a really common point of failure, the speakers. I'm talking both the main loudspeaker that plays your music and that little earpiece you use for calls. The reason these things work is because they have a tiny coil of wire inside. And for that speaker to actually make sound, that internal wire has to be a complete, unbroken loop. And guess what? Testing it is so simple. You just switch your multimeter to continuity mode, you take your two probes and touch them to the two little connection points on the speaker, and you just listen. If you hear that beep, you know for a fact that the internal wiring is good. The speaker's fine. If you hear nothing but silence, well, that means it's got an open circuit inside and it's time to replace it. Okay, next up, let's talk about fuses. These little tiny things are kind of the unsung heroes of any circuit board. See, their whole job in life is to be the weak link. They are designed to break, to create an open circuit if there's a big voltage surge that could damage the more important, more expensive parts of the phone.
So here's the crucial thing to understand. A good, healthy fuse must have continuity. When you test it from one end to the other, it's got to beep. If you test a fuse and you get silence, that means it's blown. But here's the twist. The fuse isn't faulty. It actually did its job perfectly. It sacrificed itself to protect the phone. All you got to do is replace it.
All right, moving on to coils. Now, just like speakers, these things have a long wire wound up inside of them. So our first test is exactly the same. A good coil should always beep when you test it from end to end. Easy enough. But this is where things get a little more interesting. With a coil, there's a second test we have to do, and it's arguably even more important.
So after you've confirmed it beeps from one end to the other, you do this second check. You leave one probe on the coil, and you take the other probe and touch it to a ground point, like any metal part of the phone's frame. Now this time, you want to hear silence. If it beeps, that means electricity is leaking from that coil straight to the ground. We call that a short, and that is a very serious problem. It can absolutely stop a phone from even turning on.
And you know what? We apply this exact same logic when we're testing something like an antenna cable. For you to get a good signal, a couple of things have to be true. First, the path for the signal itself, that little inner wire, has to be complete from end to end. So that should beep. The outer metal shield also needs to be complete end to end. But, and this is the critical part, the inner wire and the outer shield must never, ever touch each other. If you test the inner wire against the outer shield, you need to hear silence. A beep there means you have a short, and that will absolutely destroy your cell reception.
Okay, so that was a lot to take in. Here's a quick little summary of everything we've just covered. Just think of this as your go-to cheat sheet. For a speaker or a good fuse, you're looking for that beep. For a coil, it's a beep end-to-end, but absolute silence when you test it to ground. And for an antenna cable, you need that perfect mix. Beeps along the paths, but silence between them. Get that right, and you've got a clear signal.
So what's the big takeaway here? What's the bottom line? We've talked about beeps and silence, we've looked at coils and fuses, but what does mastering this one single test really mean for you? Whether you're a pro repair tech or just a hobbyist, why does this matter so much?
It matters because the continuity test is what separates guessing from knowing. It's the tool that lets you stop just randomly swapping out parts, hoping for the best, and start making actual, informed decisions. You don't have to wonder anymore if a speaker is bad. You can test it in 5 seconds and know for sure. And that saves you time, it saves you money on parts you didn't need, and man, it saves you a ton of frustration.
So there you have it. You now have the fundamental skill you need to start troubleshooting with real confidence. That beep, it's your confirmation. It's your clue. It's your guide. It really is a diagnostic superpower. So go on, grab a multimeter, find that old broken gadget you've got sitting in a drawer somewhere, and just listen. What's it going to tell you?